So, looking at page 5, can someone hit the light for me, please? So again, we are going to fill in this chart together and this all covers what we talked about yesterday. All right. So we're dealing with the special quadrilaterals that we talked about yesterday, specifically parallelogram, rectangle, rhombus, and square. Those are typically the 4 that we'll use in this class. We'll use kite and trapezoid a little bit, but when it comes to proofs, those 4 are kind of the key. All right. So first off, we're just talking about their sides and angles. So can someone raise their, or let's do this way. So thumbs up for yes, thumbs down for no. Does a parallelogram have 4 sides? Yes, it does. So we're going to put a check. Does a rectangle have 4 sides? Thumbs up, thumbs down. Yes. Does a rhombus? Yes. And obviously a square does as well. They're all quadrilaterals. Now, opposite sides are parallel. Isn't that true for all of them? Yes or no? So thumbs up for yes, thumbs down for no. So all their opposite sides are parallel. That is true. Now, is it true that all the opposite sides are congruent? Yes, no, or maybe. So we're not saying all the sides are congruent, just the opposite sides. So think about it carefully. Yes, no, what do you think? It's actually all true. Because I'm assuming the holdup is with rhombus and square because all the sides are congruent. So it is true because if you think about it, if I had a square, if this side was 4, what does its opposite side have to be? 4. So if this side was 4, what does its opposite side have to be? So in fact, the opposite sides are congruent. Is that where that was kind of the holdup for you guys? That was what was confusing you guys? All right. So technically, the opposite sides are congruent for all 4 of those shapes. Same thing with a rhombus. Even though all 4 sides are congruent, the opposite sides are still technically congruent. All right. Now, all sides are congruent. Does all 4 shapes fit that category? Thumbs up, thumbs down. Do all 4 shapes fit that category? No, they do not. Someone raise their hand and tell me the only ones that do fit the category. Jasmine. Rhombus and square. Those are the only 2 that fit the category that all sides are congruent. What about opposite angles are congruent? What do you guys think? All 4 or some of them? Do you think all 4 have opposite angles that are congruent? Think about it carefully. So thumbs up for yes, thumbs down for no. What do you guys think? So go ahead and put your thumbs up or thumbs down, whatever you think. Okay, I see kind of a mixed reaction here. So, which shapes are kind of holding you guys up on that fact? Like, which shape is like you're thinking that the opposite angles are not congruent? So, for the ones that said no, which shape is telling you that the opposite angles are not congruent? So, let's look at it this way. Parallelogram. Are these 2 angles congruent? Yes or no? Yes. Are these 2 angles congruent? Yes. Is it true that both those 2 sets that I showed you are opposite angles? Those are congruent. Rectangle. We know they all have 90-degree angles. So, are these 2 angles congruent? Yes, they're both 90. Are these 2 angles congruent? Yes, they're both 90. Is it true that the opposite angles are congruent? Yep. They're both still opposite each other. Rhombus. Are these two angles congruent? Yes, they're opposite. Are these two angles congruent? Yes, they're opposite. And then a square is the same thing as a rectangle. Even though all four angles are exactly the same, these two angles, which are opposite from each other, are congruent, and these two angles are congruent. So guys, some of these shapes fit multiple categories in terms of their congruency. So for example, in terms of all sides are congruent and opposite sides are congruent. Both a rhombus and a square fit both categories because technically their opposite sides are congruent as well as all of their sides are congruent. It fits both categories. All right. Whereas with opposite angles are congruent, which two shapes do you think is going to fit both categories in terms of all angles are congruent? Square is one of them, but not rhombus. Rectangle. Because they both have what type of angles? 90 degrees. So when all angles are congruent, that means they're 90 degrees. That's the only way that you can have congruent angles all the way around, is if they're 90. Because if you think about it, what's 360 divided by 4? So any quadrilateral adds up to 360 degrees. If all four angles are congruent, that means if we divide 360 by 4, what do we get? 90. So that's why if all the angles are congruent, they have to be 90 degrees. So that was just dealing with the sides and the angles. Now we're going to look at the diagonals. All right. So this is a review from yesterday. First off, bisect each other. What does that mean? If they bisect each other, they cut in half. What gets cut in half specifically? The what? So for example, if I have this parallelogram, I will say that a parallelogram's diagonals bisect each other. What does that mean? So it cuts it in half, but what gets cut in half? So the diagonals bisect each other. That means they intersect halfway between both, or at the midpoint of both diagonals. So what that means is that this point of intersection is the midpoint or the halfway point for both diagonals, meaning that these two segments are congruent and these two segments are congruent. All right, that's what it means if the diagonals bisect each other. It means they cross at each other's midpoint. Does that make sense? You guys remember what a midpoint is? Right. It's halfway. It's basically the point halfway through a segment. Exactly halfway. So a parallelogram. The diagonals bisect each other. Now, remember what I said about the hierarchy. What is true about any property within the hierarchy? What did I say about that yesterday? So if we're looking at our hierarchy over here, what did I say was true about the hierarchy in terms of its properties? So let me ask you this. If we're going from parallelogram to rectangle, is it true that every rectangle has a set of opposite congruent angles like a parallelogram? They have two sets of opposite congruent angles just like a parallelogram. Is that true? Now, if we go opposite, so from rectangle to parallelogram, rectangle has all angles that are congruent or 90 degrees. Is it true that a parallelogram has all angles congruent? No. So what's true about the hierarchy? Oh boy. Who wants to be exterminator?
I'll go get Miss Angel's wasp spray.
Oh, can we go get Miss Angel's wasp spray?
Yeah, go ahead. Like,
Just be like,
I saw it, but I couldn't tell if it was.
It's on the roof. I would, whenever she sprays it, I would move because it's a 15 feet spray, so it like goes. She has it for injuries. She sprays people.
I mean,
I feel like pepper spray. That thing is
pepper spray is technically legal. We just can't have it at schools.
Yeah, she has to leave.
Okay, so moving on. So what is true about the wasp is fine, it's leaving us alone.
Don't point your pointer at it. It's fine, it's leaving us alone. Proceeds to point at it.
It ain't gonna bother it. Anyway, so what's true about the hierarchy? So what did I just basically say? What's above it? Go.
I think the door's locked. She might be in the library.
So what's above it? So any shape below a shape above it has the what properties of that shape? All the properties of that shape. Good. So in other words, since parallelogram is above all three of the other shapes and those diagonals bisect each other, that means what about the rectangle, rhombus, and square? They have it too. So that means that these all have it. All right. So that's how you know. All right. So if you don't remember which ones are which, you just got to remember at least the top one in the hierarchy, and then after that, anything below it has it as well. All right. Does anyone remember which shape in the hierarchy, the highest shape in the hierarchy that has congruent diagonals? A rectangle has congruent diagonals. So that means which, I just checked rhombus, it's a rectangle. So that means which other shape has congruent diagonals? A square, because it's below the hierarchy. So a rectangle is the highest shape in the hierarchy with congruent diagonals. So that means a square, which is lower than a rectangle, has congruent diagonals. Yeah, but it ain't going to go out. It's not even close.
You know how to use that? No, it's Murphy.
I don't want to use it.
Who knows how to use
Who's comfortable with spraying poison?
poison?
That's essentially what it is.
Like
It's
it
a-
sprays like
okay.
15
Okay, give it.
I want you to
Yeah.
imagine. I want you to
I'll
imagine.
have one of those,
Right?
bro.
It sprays far enough.
Yeah, like back up. That's our intruder drill. Yeah.
I hope your aim.
My aim was not true.
It's on the floor. Throw it away. Stop on it.
Yes.
And now the light is covered in wasp spray.
Lights don't work.
I hope so.
I don't know about the ceiling panel though.
Oh, yay.
You can't tell.
Delicious.
Can someone light that up? So no one takes a dive.
Straight on the wasp.
If anybody asks, we had nothing to do with this. Someone opened their soda and it sprayed it up to the same way. We did not go and ask them to see this.
She actually doesn't know if she was downstairs.
She wasn't. So
That was their one that's lucky back to them.
All right, guys. All right, guys. So,
My name is not true.
all right. So, now, does anyone remember the highest shape in the hierarchy where the diagonals bisect their opposite angles, meaning they cut those angles in half? Does anyone remember which shape out of these four in the hierarchy is the highest that cuts the angles in half? Rhombus. So a rhombus is the highest that bisect opposite angles. So that also means what? Square has it too. Now, does anyone remember which ones are perpendicular? So which diagonals intersect at a 90-degree angle? Does anyone remember which one is the highest in the hierarchy that has that feature? Not a rectangle. It's a rhombus. Which means what? Square has it too. So, in other words, if we're talking about these features, that's what I mean by them. The main ones you need to remember is this. Parallelograms, they bisect each other. Rectangles, the diagonals are congruent. The rhombus bisect opposite angles, and the rhombus intersects at a perpendicular. Because after that, any other shape below that in the hierarchy has that exact same feature. All right? That's how you remember it, guys. So if we're looking at the top one, we just have to remember parallelogram has 4 sides. All of them have the same thing. Parallelogram has opposite sides that are parallel. Parallelogram has opposite sides that are congruent. Rhombus has all congruent sides. Parallelogram has opposite angles that are congruent. And all angles are congruent for a rectangle. So all the highlighted check marks that I checked off, those are the highest shapes in the hierarchy that has that distinct feature. Any other shape below it in the hierarchy has that exact same feature. So in other words, it's a little less to memorize than like all the features of the others. So if you just remember the hierarchy and then that a parallelogram has all these features except for all sides are congruent and all angles are congruent, that means they all have those features. If you remember that a rectangle has all angles congruent, that means anything below a rectangle has that feature. If you remember that a rhombus has all congruent sides, that means anything below it in the hierarchy has that same feature. Same thing with diagonals. If you remember that a parallelogram's diagonals bisect each other, that means everything below it, they bisect each other. If you remember that a rectangle's diagonals are congruent, that means everything below it in the hierarchy, they're congruent. If you remember that a rhombus's diagonals bisect the opposite angles, everything below it is true. If you remember that the rhombus's diagonals intersect at a perpendicular angle or a 90-degree angle, anything below it's true. All right, does that kind of help you guys in terms of the memorizing part? Or just remembering? So a little bit less to memorize because there's a little less shapes there. All right. So let's look at some true or false statements. Let's just do 9 through 17 real quick. So thumbs up for true, thumbs down for false. So think about all these carefully. All quadrilaterals are parallelograms, true or false? Thumbs up for true, thumbs down for false. Go. That is most certainly false. Because trapezoids and kites exist. All parallelograms are quadrilaterals, true or false? That's definitely true. A square is a parallelogram, true or false? That's true. Parallelograms higher in the hierarchy. A parallelogram with a right angle is a square. Is that always true? Right, it's false because rectangles exist. All rectangles are parallelograms, true or false? That is definitely true. All rhombuses are squares, true or false? That is false. It's higher in the hierarchy. All squares are rectangles, true or false? True. Rectangles are higher in the hierarchy than squares. A parallelogram with 4 congruent sides is a square. Is that always true? Right, that's false because rhombuses exist. And a parallelogram with perpendicular diagonals is a rhombus. Is that always true? Sure? So it is always true because what's a square considered? a rhombus. Because the only other one that has perpendicular diagonals is a square, and technically all squares are rhombuses. All right, any questions on those? All right, so let's do this. Let's take our 5-minute break now. Then when we come back, we're going to do the blue graphic organizer. Or the green, no, it's the green one. We're going to do the green graphic organizer. All right, so I'm going to go ahead and set the timer for 5 minutes. Make sure you're back before then. Oh dear.
We're quoting you. No, you're getting quoted now.
Oh God.
Your favorite students are quoting you now.
Oh God.
Give us some.
My aim is not true.
That's already. Yeah, we already have one. That's why you started the quote wall.
Yes, let me write you.
You want this wall? We do this wall.
Sure.
They're little sticky notes. They're not that bad. We're gonna get them up there so
Make sure
far.
there's nothing inappropriate.
No, we put the.
No, it's like my aim is not true.
They're in an
They're in an open
open
relationship.
relationship.
They're married and shortly divorced.
They're married. They're not bad things. They're never bad things.
I hope not.
Unless you say something really
I'm a little bit
outrageous.
more loose with what I say with y'all than I am with my friends.
You're probably gonna read that and be like, what is she talking about? My aim is not.
I'm worried I got the outlet over in the corner.
Don't you love when your students quote you?
Yeah, you got that now.
They're like little, they're just little sticky notes. They're not-
I mean, I remember last year in Jacksonville, I said finagle to my kids one time, talking about it, and that's all they could say at that point. Like, they would say, "We have to finagle it, we have to finagle it."
It just means nothing.
You're gonna get to take those down at the end of the year and just go through.
No,
November, your
If I
senior
come back,
year,
if I ever come back here and
your
you're
class.
missing, I'm gonna be mad. And they're weird. There you go.
I think I have some bigger students like those ones.
If she ever says something really big with her, it makes me want to fall off.
Oh, your chair screams. What the hell is that? Your chair. Your chair screams. Like, what is that?
You look scared. You said these things.
You said these things.
Yes, but I don't want reminders that I said those things.
No, it's.
I tried to
You
put
can
dates
ask
on it.
any of my friends, I say some out-of-pocket stuff.
Oh no, I do too, and that's why there's a quote channel. And whenever I say something, I put it there. Like when I said one me one time, and everyone thought it was hilarious because they never heard it before. It was the "You I Like Papa" from freaking Stranger Things, and they never heard it before apparently. No, you never hear that.
Glad to know that the ceiling tile is drying slowly.
Very slowly. That tells you how warm it is in this room.
We're gonna come back in the room tomorrow and it's like wall spray.
Mmm.
Delicious.
At least wasp spray doesn't smell as bad as like ant spray or something. You don't really smell it.
And it's also up in the ceiling. Who people smell it? People are
Yeah. Except for if it like sits in the room.
Do y'all smell it over there? Okay.
Oh,
I'll
That's
make
awful.
sure, because if we need to, we all over here, we can.
vacate the premises of dead wasp.
It's still on the floor. Did someone pick it up?
Nah, Corey got it.
Okay.
You guys like our quote wall? The 4 quotes that are up there right now.
They got the one from the day with the wasp spray.
They're shaking her head. It's crazy.
We're gonna get bigger, colorful sticky notes. Just put them up there.
The more outrageous things you say, the different colors they are.
We're gonna start color coding them.
Yeah. Green is like, it's okay. Pink would be like really outrageous.
All I know is I get that from my mother.
You guys like our quote wall?
The quote wall.
But everything just sort of
Miss
like
Murphy
that.
does not like it.
Yeah, sticking it from wall. And say things.
The bright blue sticky notes on the white wall.
They say random things, but that's what they said. Like the one time that she said they were married. And then they were in a open relationship. While being married still.
Hey, swears exist.
We didn't quote swears of it, did we?
Go down to Miami, Florida, Fort Lauderdale, you'll see a lot of swears. Them old ones be crazy.
Like the one when you sat at house you're like, oh no.
That one you're not allowed to.
No, that was
Oh, what was the one that you made up one? You made up a word. You made up a word? She made up a word. She made up like she didn't say cuss words, so she made up some other word.
Son of a biscuit eater, dang flabby. Like, I
You're
got
so funny.
All right, guys, let's go ahead and
Why can't we watch that? It's only 32 seconds.
No. All right, guys. So let's get back to it. So, shh. We're looking at that green graphic organizer on the front. So, the one with the triangles. So basically, with proofs, a lot of proofs come from the congruence postulates of triangles. All right, you did this back in math too, at least the congruence postulates. So we're just going to review them real quick just so you guys remember. All right. So, does anyone remember what SSS means? Side, side, side. So these are all the ways that triangles can be congruent, meaning they're the exact same size and shape. So that means that all the corresponding sides, so if I had A, B, C, and then D, E, F, all right, the corresponding side for A, B, and D would be D, E, so these two would be congruent. BC is the same as EF, so these two are congruent. And then these three are congruent. All right, if you have 3 sets of congruent sides, then those two triangles are congruent by side, side, side. Anyone remember what ASA means? Angle, side, angle, ASA. So, angle, side, angle. So essentially that means you have 2 angles that are congruent. So again, A, B, C, and D, E, F. Basically somewhere you have 2 angles that are congruent and then a side directly in between those 2 angles. So those 2 angles have to share a side that makes them up. All right. So the corresponding over here would be it'd be these two. And then this side. So remember, they have to be the corresponding or the matching side, all right, that are congruent. Same thing with the angles. They have to be the corresponding angle that's congruent. All right, who remembers what SAS means? Side, angle, side. So similar to angle, side, angle, but instead of 2 angles and a side in between them, it's 2 sides that have an angle directly in between them. So my 2 sides again, A, B, C, D, F, E. All right. So let's say this angle was congruent to this angle, and then they had this side in common and this side in common. So that would be these 2 sides. So in other words, the 2 sides are the sides that make up that angle in between them. All right, that's another way to remember it. AAS, who remembers what that is? Angle, angle, side. All right, so yeah.
Another wasp doesn't come in.
It's okay, because that's
We should have just held on to the wasp right?
we should have spent the wasp right. There's probably a wasp in this outside.
No, there's not. It's just, it comes from the tree.
There's actually a wasp nest in the hallway. Oh, just chilling.
All right, so angle, that means that two angles in order if you're going around, and then a side directly after the second angle. So over here, if it was D, E, and F, angle, angle, and then a side. What's the last one stand for? Hypotenuse leg, good. So remember, this one you can only use with right triangles, all right? So it has to have that 90-degree angle. It has to be with a right triangle. And basically all that one says is that if a hypotenuse of a right triangle and one of its legs are congruent, then the whole thing is congruent. So in other words, if ACB, DEF, if the hypotenuse of both are congruent and one leg is congruent, then both triangles are congruent. What's the only postulate that you're not allowed to have? Angle, side, side. So I don't want any in my class. All right.
That's the question.
So
She said,
it's basically, it's not enough information. So that's why you can't have ASS, because it's not enough information. Because you either need to have at least two angles that are congruent, because then you could use the triangle sum theorem to get the other angle, or you need at least two sides that are congruent, because no. Yeah.
So like, for a side angle side, why wouldn't all the angles be, like, wouldn't all the angles be congruent?
Not technically.
So, how do you know?
So technically all the angles would be congruent if we can show that the triangle is congruent. So it's kind of like a cause and effect. So if we can say that a triangle is congruent by side angle side, because we know that at least one of the sides, at least two of the sides are congruent, and the angle in between those two sides are congruent, then the effect is that we have enough information to get the other angles. So the way it works is that if you think about it, all right, the sides make up the angles, right? And then the distance between the two sides and one of the angles has to be the same length. So in other words, if you have two of the same angle made from the same length of the side, that means the space between the two ends of the sides has to be the same length. So that proves that all three sides are congruent. And then because of that same length side, that means that these other two angles are congruent. That's why it proves congruency. Same thing with the other ones. So like with two angles, if you know that at least two angles are congruent, that means that that third angle has to be the same as the other third angle, because just triangle sum theorem. But then when you throw in the side in there, all right, what happens is if you throw in the side, that means one of the sides is making up that third angle, all right? So by extension, all the other sides connected to it, this side would have to be congruent to make this angle here, all right? And so then by extension, this length between this angle would be the same. So it's basically just memorize them. There's reasons I can explain why they work, but it gets a little confusing. All right. Now, one other thing is that after proving congruent triangles using corresponding parts of congruent triangles, CPCTC to show that other corresponding sides and angles are congruent. So this more so becomes part of proofs. So in other words, if we can show that, we have a side angle side somewhere, that means that the two other angles that are not mentioned are automatically congruent because of corresponding parts of congruent triangles. Meaning that the matching angles of the other triangles of the two triangles are congruent. Same thing with the sides. The matching sides would be congruent. That's what corresponding parts means. Corresponding means it's the same side. All right. If you're looking at the triangle from the same viewpoint, it'd be the exact same side. That's what that means. So that's why, like, for example, with side angle side, A, B, and D, E are the same because they both look like they're the shortest side. That they're corresponding. They're the exact same side. Does that make sense? All right. And then the other part is proofs. So with proofs, a lot of proofs comes from all right. So a lot of proofs comes from different reasons that we just need to recap. All right. You learn these back in math too, but we're just going to look at them again. So turn to the back side of that green graphic organizer. So with geometry proof statements and reasons. So whenever you do a proof, what we'll find out tomorrow is that there's always a statement. So that's you saying these two angles are congruent or these two sides are congruent. And the reason is the why. So it's like, why can we say that those two angles are congruent? Why can we say that those two sides are congruent? So on and so forth. All right. So the statement is what we're saying. The statement is the what. The reason is the why. All right. Now, I'm just going to list the ones that are kind of review from Math 2, specifically just a couple of geometric properties that you learned back in Math 2 that don't quite relate to quadrilaterals. All right, they more so have to do with either triangles or angles or parallel lines. All right. So this first one doesn't really have a diagram, but if A equals B and B equals C, then A equals C. And the reason that is, so think about this with numbers. If A and B were both equal to 1, so 1 equals 1, I replace A and B with 1. That means C has to be what? So let's put it this way. Let's say A is equal to 1, B is equal to 1. So that means 1 is equal to 1. We then know that B is equal to C. So what does C equal? 1. So is it not true that C is also equal to A?
Yes.
That's why. All right. So what they did was that they substituted in the A for the B over in this category. That's why A is equal to C. So this property is called the transitive property or the substitution property. It means that we're taking something that we already know and we're replacing it. So in other words, we're taking this A, replacing this B, which is how we get A equals C. And again, that's called the transitive or substitution property. It means we're replacing a known equality into another equality of the same type. So another way you could put it is like this. So this is not true, but let's say that Corey and Landon had the exact same height. Exactly. And then I also knew that Landon has the same height as Gavin. Again, it's not true in this case, but I'm just naming names, just name names. All right. So is it also true that Corey and Gavin have the same height? Yes. Hypothetically, yes. Not truthfully, but hypothetically, yes. So if Corey and Landon have the same height, and we know that Landon and Gavin have the same height, that means that Corey and Gavin have to have the same height. That's what that means. All right. All right. The next property, all right, is what we call the reflexive property. So the reason is the reflexive property. And all that means is that something shares a side or angle. So in other words, for example, if I had this picture here, so I have two triangles, call it A, B, C, D, and they shared this side. That means that AC is obviously congruent to AC from both triangles because they share the side. All right. Then if I had this picture, let's call this EFG, and this is H, and this is I. These two triangles, the big one and then the little one right here, share this angle. So that means that angle E is congruent to angle E because that's the exact same angle. So basically we're saying even though it's technically part of two different triangles, they're connected by this side or angle. So obviously those sides and angles are equal to each other. All right, that's what's called the reflexive property. They literally share a side or an angle. And obviously, if it's the exact same side, it's equal to itself. Does that make sense? All right, the next one. Goes back to parallel lines. We talked about this a little bit the other day. So if you have two sets of parallel lines cut by a transversal, let's call this angle 1, this angle 2. And I would say that angle 1 is congruent to angle 2. Does anyone remember what this is called? Alternate interior angles. So this is alternate interior angles are congruent in parallel lines. That's what you would state if it was by alternate interior angles. All right. The next property, still looking at parallel lines cut by a transversal. But now I'm looking at this angle, which I'm going to call 1, and this angle, which I'm going to call 2. And I'm saying angle 1 plus angle 2 is equal to 180 degrees, or we're going to say that they're supplementary. Why can I say that? What property is this? Same side interior. They're on the same side of the transversal, and they're both inside the parallel lines. So this is by same side interior angles are supplementary. That's the reason that you would state. So guys, all these reasons are the way I'm writing them is exactly how you would state them in parallel lines. All right. Now let's say that I had two segments that were crossing each other. I'm going to call this angle and this angle 1 and 2. Now, these two angles, so angle 1 is congruent to angle 2. Does anyone remember why? What type of angles are these? They're opposite, but there's a special name for them. So, these, remember vertical angles? This was back in math too. So vertical angles, meaning that like if they form an X, they're opposite each other. Vertical angles are congruent. So if you have two segments, they form an X, and then you're given two of its opposite angles, so they're opposite each other. They're congruent. They're called vertical angles. All right. Then what if I had a segment and it looked like this? Let's say this was angle 1. This is angle 2. What's true about that? They're supplementary. Why? What's this type of angle called? Not quite. So remember, again, this is review from math 2. This is called a linear pair. Meaning, if it looks like what we're used to seeing when we see supplementary angles, it's called a linear pair technically. Linear pair are supplementary. All right. The next one. So let's say we had a segment A and B, and it has a midpoint M. So M is a midpoint. Does anyone remember what a midpoint means? It means it does what to the segment? Cuts it in half. It's a point that's halfway through the segment. So that means that this side and this side of the angle is congruent. Now, on the opposite hand, if we had a line cut through perfectly through the segment through the midpoint, let's call this line L. This is called a segment bisector. So remember, bisector still means to cut in half, and it still has the same property. It means that these small segments, so this small segment is congruent to this small segment because it's cut in half. So that means that segment AM is congruent to segment, not B, MC. Because the midpoint cuts the segment in half, the segment bisector cuts the segment in half. So obviously if it's cut perfectly in half, that means the tiny half pieces are exactly the same length. All right. And the reason for that is that it's a definition of segment bisector, if that's what you're given, or it's a definition of midpoint if you're given that. So you can use those two words interchangeably. So if you're given a segment bisector, that's just the definition of segment bisector. If you're given the midpoint, definition of midpoint. They both have the same property. Now, let's say we had an angle. And it's cut with another line. All right. So let's call this angle 1 and angle 2. And this line just so happens to be an angle bisector. What does that mean for angle 1 and 2 if that segment or the middle segment is an angle bisector? What does that mean? They're congruent to each other. That angle bisector cut the big angle in half, which means the tiny angles, angle 1 is congruent to the tiny angle 2. And again, that's by definition of angle bisector. Almost done, guys. Almost done. So, if we are given a congruent triangle, so we proved that the triangles are congruent by one of those postulates that we just talked about. So in other words, if I have two congruent triangles, so these two little triangles are congruent to each other. So ABC is congruent to DEF. We already proved that those two triangles are congruent from some reason. That means if I were to pick any angle, let's call this 1, this 2, any corresponding angle between the two triangles, meaning that they are in the same spot as each other. That means that angle 1 is still congruent to angle 2. If I pick any side, so any corresponding side on the congruent triangles, that means that those corresponding sides are congruent. So side BC is congruent to side EF. And the reason for that is CP CTC. And again, we can only use this after we show that we have congruent triangles. And just to recap, that stands for corresponding pairs of congruent triangles. So in other words, the shorthand CPCTC. So all of these are basic geometric stuff that you've already learned about in either Math 2 or Math 1, specifically Math 2, probably because Math 2 is more geometry heavy, and that we're going to use at some point with our proofs tomorrow. Any questions? It's so much, but on the test, I'll let you have these graphic organizers. I'm not going to make you memorize all that stuff because that's a lot. All right. CPCTC, corresponding pairs of congruent triangle. Oh, of congruent triangles are congruent. That's the other C. So if the triangles are congruent, any of the corresponding pairs, meaning angles or sides, are also congruent. I forgot the are congruent. All right. Do I want to do this? Okay, guys, we'll pick up with the other graphic organizer tomorrow. So your classwork for today is there's a short Delta Math dealing with congruent triangles. It's labeled warm up congruent triangles. All right, so go ahead and work through that.